welcome back. So we were talking about OTV in the previous video, so this will be a continuation of that discussion. We talked about underlay and we talked about how OTV works in the multicast space. So in this one, we'll mainly talk about how we can get OTV when, or how we can get the OTV working when you don't really have multicast enabled in the core, right? So a small tricky way of doing this, pretty simple actually. So let's get to it, right? Step number one, what do we do is let's go and remove the overlay which we have configured right now, right? So let's go to this OTV1 just to make sure that I show you guys that it is really, that I'm not really using multicast. What I'm going to do is I'm going to delete the overlay which I created earlier, right? I'm going to do the same thing on the other device as well. Right, there you go. Right, so it's a continuation. So, but let me actually spend a minute, to talk about what we did in the previous video. Right, we configured the underlay here. Then we also configured the, when I say underlay, we also enabled multicast here, right, in the core. We also went and configured the Hsrp, right? If you really want to look at that config, you can go back to the previous video of the series and check it out. So we configured Hsrp and spanning tree, right? Basically the switch 1.1 is the Hsrp active for VLAN 10, whereas this one, the second one, is the active for VLAN 15. Same configuration, similar configuration goes on the other side as well. And we had activated the multicast OTV only on these two devices, which is OTV11 and OTV21, and we were able to talk right between VLAN 10 and VLAN 15 in the previous video. In this one, we are going to basically again work on the same two devices, which is OTV11 and 21, but this time we are going to do it in the Unicast mode, right? So to show you that, what I have done is I have deleted the overlay right now, right? The overlay is down, so I have to reconfigure the overlay, right? So let's do that. All right, so let's look at the configuration, right? So let's come to OTV1 and let's look at show run interface gig 1. Right, on the gig 1 I have not changed anything, it's the same, right? You can technically not have this, but it's fine if you have this also, it's not going to have any impact, right? I can even remove it if needed, right? But anyway, so I have just an IP address on the gig 1, that's it. Now question time, right? So how do we really make this work? If I don't have multicast, how do we make this work? Because if you see in the previous video when we did with multicast, it was pretty simple, right? We had to define like a multicast group to which the OTV control packets will be sent. We also had to define another multicast group to which the data packets will be sent. Multicast data packets will be sent, or broadcast packets, right? But how do we do it here without multicast? So that's where there is a very interesting concept of adjacency server, right? So in your whole OTV cloud, you can pick any device as your adjacency server. In my case, I'm going to pick the OTV11 as the adjacency server. And then you can also pick one more device as a backup adjacency server in case that one goes down. So in my case, I'm going to pick the OTV12 as the backup, right? So that's it. I mean, what happens is when the OTV plane comes up or the OTV cloud comes up, right, everyone will go and register themselves with the adjacency server, right? So that's how the discovery happens. All the OTV devices here or the edge devices will get to know about all the other OTV devices because of that discovery process, right? So everyone will go and register to the adjacency server, and after that, once the discovery is done, it's pretty simple, right? So the whole multicast which was there earlier, that was facilitating that. It was facilitating the discovery part, it was facilitating the talking part. But here, it's basically nothing but head-end replication, right? Once the adjacency server, say in this case OTV11, has all the information about all the other OTV devices, it is going to just replicate the control information to all the devices. It is going to basically send all the information, it's basically going to act like a route reflector, right, in simple terms, right? It's going to reflect all the MAC routes which it is learning to all the other devices, as simple as that, right? So we really don't want multicast in this in this configuration. We are just going to use the adjacency server, and that's how OTV works in the Unicast space. Cool. So what are the configuration changes, right? Nothing actually, pretty simple. So let's get to it, right? So let's go and say conf t interface overlay 1, okay, and the join interface is still there, so let's go and configure that. We'll configure the join interface that was there earlier as well. I'm going to configure now as well. but the new command which you need to configure is Otv Adjacency Unicast only, right? Adjacency server. So you're basically making OTV11 as the master adjacency server. And then you also want to configure the backup, right? So for that, the command is, you say OTV use adjacency server, and then provide my own IP address first because I am the primary. Then provide the IP address of the secondary or the backup, which is 12, OTV 12, right? Right now there is nothing configured on the other guy, so technically it will be of no use. The backup will not be helpful at all because we haven't configured anything on OTV 12, right? But anyway, we are just going to configure it for now because my primary is working, so my OTV should come up, right? Yeah, the rest of the stuff is pretty simple like we did earlier, right? We just need to enable the service instance for the two VLANs which we have. In my case, it is VLAN 10 and VLAN 15. This is there earlier as well, nothing different here, right? We did the same thing in multicast as well, no difference. So let me go exit and let's do a no shut. Now slowly the OTV plane will start coming up, and while it is coming up, what I'll do is quickly I'll pause the video and I'll quickly do the configuration on the other side. Alright, that is done as well. So it'll obviously take few seconds or probably a couple of minutes to come up. So meanwhile, let me show you the configuration which I just now did here, right? So let me clear the screen. So if I do show run interface overlay and 1, what do we have? So we have got the OTV join interface, but you see that we are not going to configure the OTV adjacency server unicast only command here. Because why? Because we just, like we discussed, OTV11 is the adjacency server and OTV12 is the backup, right? Rest of all the guys, we are going to point them to OTV11 and OTV12. That's it. That's why we just have this one command on here, right? Unlike, let me show you here, right? Unlike we had, maybe better to show it to you here, show run interface overlay 1, right? You see here we had two commands, right? One was the command which was basically telling that this OTV11 is going to be my adjacency server, and the other one was talking about the backup. But here in this one we just have one single command, right? And the rest is pretty simple. We just have enabled the two VLANs which we are going to extend, right? So that's pretty much it. Now the waiting game starts, right? So we'll wait, show OTV, there you go. I don't think it's still ready, it is telling no, so we'll wait. Other way of checking is, like I've told, you can do show OTV VLANs. Sorry, I made a mistake. Show OTV VLAN. Right, there you go, it's showing inactive. So our waiting game starts. We'll come back once it is done. Alright, so time to check. We'll say show OTV on OTV11. Yeah, looks good. Let's analyze this. So it says state is up. It's all forward enabled, forward ready. It is the AAD server as well. Technically it will be the AAD server for both the VLANs since we just have one OTV device on each side. It is not the backup, right? Because this is the primary, so it is not the backup. It is AAD capable. Join interface is mentioned and IP address is mentioned, unicast only, and you can see here the primary and secondary IPs are mentioned, right? Cool, so that's it. Let's look at other stuff. You can say show OTV adjacency maybe. There you go, it has established the adjacency. What else do you want to check? You want to see the routes. Show OTV route, right? So you can see all the routes are there. Maybe if you want to make it simpler, we can say bridge domain 10, and you can see the two hosts, right, which we have. One is 10.50 and 10.100. So this is a site one. This is learned locally, this is learned via ISS, right? What we can do is we can go here and we can ping as well. Ping 192.168.10.100, which is the host in the other site, and it works, right? We can try the same thing here. Enable. So we can do ping 192.168.15.100, right? That works as well, right? So we have actually achieved the same thing which we did, in the previous video, but we did it using multicast in the previous video. But in this video, we did it using just unicast, right? Without using any multicast control groups or data groups. Cool. Next, what do we do next? So as per our if you go back here, let's see what did we discuss, right? So we did underlay, we did multicast, we did unicast. Next we are going to redundancy. Cool. So redundancy means we'll go and configure OTV 12 and OTV 22. So let's get to it. So let's get to OTV 12 first, right? So let's go to OTV 12. This is my OTV 12. What is there on this? Right now it just has show run interface gig 1. It just has configuration on gig 1, nothing on gig 2. So let's get to configuring it, right? So where is my 12? Yeah, so I've got it. So let's configure gig 2. Okay, so gig 2, I'm just gonna, it's going to be very similar to, let me actually show you that, right? So if you can do show run interface gig 2, right? This is exactly what we are going to put on this device, right? Nothing different, because we just want to extend 10 and 15, and this is going to be my site VLAN, and the site VLAN should be same on the devices in the same site. So that's being put. Now next we have to put in the OTV related configuration, or let's actually first wrap up the spanning tree, right? We need to have spanning tree PBST enabled, so let's do that. And the next would be enabling OTV, the site identifier and the bridge domain. So let's do that, right? The site identifier should be 0x1 because it is the it's in the same site as OTV11, and the site bridge domain will be 111 because this is the site VLAN. So let's go and put that. Okay, and the last part of the configuration would be what? Overlay, right? Let's put the configuration of the overlay as well. We are doing this in the unicast mode. We are no longer going back to the multicast. We are continuing with the unicast mode. So again, same configuration which we had, let me actually show you that as well. So if you come here, if you do show run interface overlay 1, right? Exactly same configuration we are going to dump on my OTV 12 as well, right? You might ask, why are you putting this, right? This device is not the primary adjacency server, right? But we still need to put this because it is the backup adjacency server, right? On both of these devices you need to put this command, but the rest of the devices, that is OTV 21 and 22, you don't have to put that, right? And the rest of the two things are nothing but extending VLAN 10 and VLAN 15. So if everything works fine, okay, that is going in good. And let me just exit out of this and do a no shut. I have a feeling I probably did not do a no shut on the gig interface too, so let me do that as well. Or maybe I did, I'm not sure, but just to be sure. Alright, so again, gotta wait now. So while we wait for this, what I'm going to do is I'm going to do the exact same configuration on OTV 22 and I'll be back in a minute. Okay. Alright, I've done the configuration. Maybe quickly I can show it to you. Show run interface overlay 1, right? What do we have here? Very similar to what we did on OTV 12, right? Except that we have removed that extra command. Actually, this is exactly same as what we did on OTV 21, right? We just have one single command which is pointing this particular OTV cloud to this device, which is the primary AED. Excuse me. Sorry, not AED, primary adjacency server, and the second one, which is the backup adjacency server, right? But now we gotta wait, right? Like I've told before, see, we'll have to do show VTV VLAN. So it will be in inactive state for a few minutes, and then it is going to transition. So we'll wait until that happens and we'll be back. All right, looks like it has transitioned. So let's look at first OTV 12, right? So if I do show OTV, you can see that it's up. You can see because this guy is backup AED server, right? So you can see it is mentioned as yes over here. It is not the primary, right? So that's why it is no, and it has the IP addresses. So we can do show OTV VLAN just to see everything is good, yes. But look at here what is happening, right? So actually let's compare this with the output of this guy. Sorry, VLAN, right? So we know we have two VLANs in the site, right? We have 10 and 15, but you see it has intelligently picked up, right? This is the whole advantage of doing multi-homing, right? Because we did multi-homing, right? From the diagram, if you see, what it has done is it has picked up OTV 11, right? OTV 11 device as the primary, right, or the forwarding AED for VLAN 10, right, and for the other VLAN, which is an odd number, right, it has picked the second one, right. So it has intelligently done that. So now you can see here it is active, right. This guy is active for what? VLAN 10, whereas it is OTV 11 is inactive, right. It is inactive for VLAN 15 because the AED for VLAN 15 is the other device, which is the 12th. So you can see here it is active, right. So this really prevents any kind of loops in your network, right. So that's why without STP also, I mean STP is not sent across OTV. That's a very important point. And even though there is no STP, will not have any loops, because all the traffic which is coming out from VLAN 10 will be forwarded by this AED, whereas coming from VLAN 15, right, any traffic coming from 15 will be sent or forwarded by this AED, right. So there won't be any kind of loops coming into play. Okay, so that's one important point which I want to show you, how the even odd algorithm, right, comes into play, and it picks one VLAN and it picks one VLAN and gives it to one of the AED, and it picks the other VLAN and gives it to the other AED, right. So that's pretty cool. And yeah, apart from that, I mean the ping should still work, right. We can check that if you want. We can come to this guy and we can do a ping to 192.168.10.100, right. There you go. Ping still works. Connectivity is all good. Though we have added redundancy, nothing has and there is no issue at all. Forwarding is as usual. It's just that we have added redundancy. We have added just one more AED device, which basically now forwards one of the VLAN, right. So kind of like load balancing, you can say, right. So that this topic is basically what we call as multi-homing, right. Cool. So we did redundancy. One last topic to be done, and then we'll be done with OTV, right. What is the last topic? Hsrp. Okay. So with Hsrp, one interesting problem which comes into play is, right, in my topology, let me use the pen, right. In my topology, what I've done is I have kind of like using the pen. Yeah. So I've used the same Hsrp gateway on both the sides, right. I've configured the Hsrp gateway here, 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 and here, but I've used the same IP address, right, .254, right. So what if the Hsrp packets, because this is L2, everything is L2. So what if the Hsrp packets are also sent like this, right, from one side to other? What would that cause, right? That would cause some kind of an unoptimal or unoptimal forwarding, right? Because think of this way, right? So if let me just erase this. Okay. So what if I want to say talk between, so let me grab this, right? What if I want to talk between VLAN 10 and 15? I would want the routing to happen like this, right? I would want this default gateway to kick in, right? Or if I want 15 to talk to 10, I want the local default gateways to kick in and do the routing for me, right? But if the Hsrp packets are basically sent across sites, there is a possibility, right, that because it's the same Hsrp gateway, there is a possibility that the packets might you'll have to send the data all the way to the other side, then turn it back and come here like this, right? So it's not really optimal, right? Because the gateway might end up being this one, right, which is on the other side. So it's really not optimal. So you want, for any kind of inter VLAN routing, you would want the gateway which is closest to you to be picked up, right? So to do this, what they do is they filter out the Hsrp packets, right? So when the packets are sent up to your OTV over here on these L2 interfaces, you can put a small MAC access list, right? And you can filter out the OTV filter out the Hsrp packets. That way Hsrp virtual IPs are not, or virtual MAC addresses are not even learned, right? Let me actually show you what I actually mean, right? So if I come back here, let me just grab that. So if I come back to my OTV 11, let's go to OTV 11, and if I do show OTV route, let's just look at probably bridge domain just 10 or VLAN 10, right? If you observe carefully here, see here, this is nothing but this is the MAC address of what? The Hsrp, right? I know I've played around with the Hsrp nicely before, so I do know that the MAC address is of this format. But just to prove you, what I can do is I can simply go to probably one of the device and I can do show IPRP 192.168.10.254, right? See here, isn't that the same MAC address which you see here, right? Because my Hsrp packets are sent all the way up till the OTV, what is happening is it is learning these virtual MAC addresses as well, right? And there is a possibility that it can create some kind of an optimal forwarding. So what we'll do now is we'll filter out this Hsrp packets, right? So we'll just create a MAC access list and we'll filter it out, and I'll show you. It's pretty simple, right? So how do we do that? I'll do it on one and then probably do it on the other while I'm not recording, right? There we go. So we'll go into the config mode and we just create a access list. How do you create an access list? Let me clear the screen. It's simply nothing but MAC access list and give a name. It should be extended. Let's go with extended. Let's put a name, right? We'll say OTV filter and we'll say Hsrp. Okay. What do we deny? So we want to deny, and we want to deny those. Let's grab that MAC address, right? It will be of this format. So let's grab that. So all the Hsrp virtual MAC addresses are of that format. So let's grab that and let's go and put 00 at the end, because we can use the wildcard mask at the other end, right? So we're going to say 00 and FF, right? Because these two can be anything. This much is constant for all your Hsrp virtual MAC addresses. This will be constant. Only the last two, 8 bits, last 8 bits are going to change. So I'm going to put a FF over there and I'm going to say any, right? The rest is I'm going to permit any. Cool. That's the MAC access list. Now where do you want to put this? We'll put it on this interface. Which one? This trunk interface, like gig 2. So we're going to put it on the gig interface. How do you put it? You're going to say gig 2, right? And we will basically go inside that service instance which we have already defined, right? Service instance 10 and Ethernet, right? And we'll say just like any MAC, just like any access list, we are going to say MAC access group. We'll just give this name and what? We'll say in which direction? In the inward direction. Cool. We'll do the same thing for the other guy as well, which is the 15. There you go. As simple as that, guys, right? Now let me quickly do this on all the rest of the 3 boxes as well. Alright, so I've put the same MAC access list on all the 4 boxes, and what I also did was I just bounced the overlay interface, because I want to show you the route table, right? The MAC route table will no longer have that MAC address which I was showing you earlier, right? It will basically, once it comes back up, it will no longer have this entry, right? Because we have kind of blocked it, right? I just bounced it, so as usual it will take some time, I believe. So there you go, it's inactive, so it will take some time. So I'll be back in a couple of minutes. All right, so you can see my OTV has come up now. You can check this with show OTV VLANs, right? So it's gone back to the original state as earlier, and you can see the show OTV routes as well. And you see, you no longer see those we don't see those Hsrp gateways appearing here because we have filtered it out, right? And we have connectivity between the 2 sites, which is if I do ping 192.168.10.100, there you go, we have the connectivity, right? So hope that was useful, guys. That was everything which I wanted to cover in OTV. Just to recap, what we did was, do we have it here? Maybe I removed it. Did I? Probably. Yeah, I think I removed it. Anyway, so what did we kind of do in the 2 videos, right? We talked about the underlay. We brought up the underlay. We brought up the multicast underlay, right? Then we talked about how OTV works in a multicast environment, right? When the transport supports multicast. Second is we went about also trying out OTV in a unicast environment, right? We learned about how to configure adjacency servers. Adjacency server is like a single point, where all the other OTV edges will come and register, and they will get all the information, all the control plane information from this adjacency server, right? So that's how we did it. And then we talked about redundancy, right? How we can add redundancy and how that intelligent, load balancing happens, right? One VLAN traffic is sent to one, AD, and the other VLAN traffic or the odd VLAN is sent to the other, AD. So we looked at that, and then finally we talked about how we can filter out the Hsrp gateways, right? We are preventing Hsrp MAC addresses to be learned, on the OTV, right? So we learned that as well, right? Hope this has been useful. Do check out both the videos, and thanks again for watching. Have a good one. Bye guys.